Hey, what up, this is Yatin and welcome back to Thermoforge for the second video. So today I'm going to be going into the advantages and disadvantages of thermoplastic composites. And what you will realize going through this video is a lot of these disadvantages are actually not what they seem to be. So let me not waste any more time and get straight into it. So the first thing I wanted to get into would be chemical resistance. I'll bring you back to our first video and you will remember that Thermosets composites, which is conventional composites, the material is going to cross-link and the cross-linking ends up into a very stable material. And when you compare that to thermoplastic composites, there is no cross-linking, so that material can melt over and over again. So for chemical resistance, the reason why you want chemical resistance would be applications where you have harsh environments. So you have, say, oil and gas, you have marine environment, and even in automotive, where, for example, you will have an engine bay where you have a lot of chemicals in there and you want the components in there to have longevity for the lifetime of a car. And as you can imagine, thermoset composites perform very well there. And they perform very well because the materials cross-link, therefore very stable. Whereas thermoplastic composites, the answer to that really depends. And it really depends on what type of thermoplastic composites. So I have this picture here from the company Toray. And what they have to the left is, you can see at the bottom, amorphous materials, and to the right, semi-crystallines. So these are two different types of thermoplastic composites. And generally speaking, amorphous materials have a lot lower chemical resistance, and semi-crystallines are a lot more stable when exposed to chemicals. So let me give you a bit more of a worked example here. So if you look at an aircraft, for the interior of the aircraft, this is an environment which is not exposed to a lot of harsh chemicals. So you have humans in there, therefore the most that you will see will be cleaning agents, which are pretty mild. And amorphous materials are very well suited for that. But also what is really good about interiors is, if you were to use amorphous materials, you could actually adhesive bond these materials very easily compared to bonding semi-crystallines or thermosets, which are quite difficult to use adhesives. The next one would be if we will look at the exterior of an aircraft. Now, in cold countries, exterior of aircrafts are exposed to chemicals such as de-icing agents. De-icing agents are really harsh chemicals where, generally speaking, you would rather lean on a semi-crystalline type material, say PEEK, PPS. Also, this is the kind of structure that you would be painting, and you might be getting rid of the paint and then getting new paint in. So paint stripping agents are also very harsh, and you would rather be using a semi-crystalline material for this. Now, thermosets are stiff material, but the stiffness comes at a cost in certain applications where the material can be brittle. Whereas on the other side, thermoplastic materials are a lot more flexible and also a lot tougher. Now, what this means is the toughness can actually be used in certain applications. If you were to look at on a car, the front pillars, say the crash structures, you would rather make it out of the thermoplastic material, which is tough, therefore will crumple and absorb a lot of the loading, compared to a thermoset material, which is stiff, therefore would shatter a lot more easily. So that is an application for thermoplastic composites. And also you have applications such as, say, winter sports. You will be using protective gear, and thermoplastic materials are perfect for this. And also in defense applications, for example, if you were to be doing some demining and you would be using protective equipment, thermoplastics are perfect for these. Now, the other aspect of toughness is also fatigue. So a material which is tough is also a material which is pretty good at fatigue performance for the most part. And thermoplastics are no different. Thermoplastic composites have very good fatigue performance. Say you have an aircraft that needs 20 to 30 years in service life, thermoplastic composites will perform very well in this application. And as a reminder, fatigue is the cyclical loading over time of a material, and thermoplastic composites brilliant in this application. The next thing to think about is the thermal performance of this material. So generally speaking, when it comes to heat resistance, thermosets, again, the cross-linking makes thermosets very stable even up until high temperatures. Whereas for thermoplastics, what you need to do is you need to be very selective about what material you're using. Say if you're using a PEEK material, which is a semi-crystalline, they are reasonably good at high temperatures, and in the amorphous material, you will be using a PEI material, which is a lot better for these applications. The next thing is also creep. Creep is you take a material and then you load it while it's exposed to a certain amount of temperature. And over time, creep just means that the material will slowly deform. Thermoset material are very good when it comes to resistance to creep material. That's simply because, again, the cross-linking. But when it comes to thermoplastics, while the thermoplastic on its own is not very good for creep, when you have fibers within your thermoplastic composites, the fibers actually really reduce creep. So especially if you have an application where creep might be an issue, if you're using continuous fibers, the fibers do not stretch, therefore creep is not really an issue. So it might not be too much of a concern depending on what applications and what formulations that you're using. Now, thermosets are brilliant for low volume. So if you're making a couple of parts, thermosets are easy and cheap to process. But if you have a lot of parts to make, thermoplastic composites are brilliant for automation, therefore automation friendly, and then you invest the money and then you can make a lot of parts at low cost. The other angle is how much pre-processing is required. Thermoplastic materials do not require freezers like a thermoset pre-preg. So you can keep these at room temperature. There's no traceability implications, therefore cost. So it's a lot easier. And the cutting and trimming of these material is also quite simple. So you would use standard technology like a water jet or some sort of CNC machining type technology. And the waste product from these in a thermoset, usually they go to a landfill. For thermoplastic composites, you can actually recycle these material and then they just get reused as fillers for injection molding or compression molding. So there's a sustainability aspect within that pre-processing. Thermosets take a long time, but thermoplastics is so much faster. There's no curing requirements. You can process this material within minutes and then they just solidify back to room temperature. So processing time is very fast. Processing time also means processing cost. So this is a lot cheaper. And finally, the joining. When it comes to most composites, you can use adhesives and fasteners. Using adhesives in thermosets is a bit of a challenge because you have to surface prep and use some fairly harsh adhesives. Whereas for thermoplastic, especially for amorphous materials, this is a lot easier to get off-the-shelf adhesives, which are a lot cheaper. And the other opportunity is because the material can be melted over and over again, you can actually weld thermoplastic composites. So say you're using ultrasonic welding, the process time on this is less than 1 second usually. So it's very fast. And if you're using, say, induction welding, again, these are extremely fast technologies. And therefore, your investment is in the equipment, but the cycle time in terms of welding is usually very, very fast, which is quite an opportunity, and we don't have any consumable cost. As you can see with thermoplastic composites, there are advantages and there are disadvantages. But what's really interesting about these disadvantages is when you zoom in and you really look closer, it is more of an attribute difference. And an attribute difference could be an advantage in a different market or a different application. And that's where thermoplastic composites are simply different, and then they bring in new opportunities. So I hope that today's videos kind of described the different opportunities and the different markets that thermoplastic composites can be positioned in, I would suggest that you click on the subscribe button below if you haven't done so, and I will see you in the next video where I have quite a treat lined up. Up until then, I'll see you. Peace.